All right. Very good morning. Very good evening, guys. Hope you guys see my screen and then able to hear my voice. All right. So can somebody confirm on that? We can get started. All right. Thanks for confirmation. Okay. So let's quickly recap what we covered yesterday, and then we'll continue from there. A few more topics for today. So we started with the introduction about your instructor. That is me. So my overall experience and areas of expertise and how my journey has started. So we started explaining on that, and followed by uh, we gone over the course curriculum. So if you missed it, so you can go ahead and then refer this particular blog, which has all the course curriculum details. Those are the course curriculum details. So what we explained yesterday, what are the topics we're going to cover here in this course. So we discussed all of these topics in details. So if whoever missed yesterday's session, please refer that recording. We explained each and every topic in details what we're going to cover in this course. And at the same time, if you're looking for some alternative schedule or new batch details and all, you can refer in the same malik034blogspot.com. There's a upcoming batch details. So right now, what we're covering is about this batch. So followed by we'll be having a rack batch. We'll be starting in next month, July 6th. It's a weekend batch. So yesterday we started this weekday batch. So if there's any other upcoming batches, will be scheduled in this upcoming batch details. Right. So followed by we explained about the course duration, timings, fee structure. So as we mentioned yesterday and today are going to be two demo sessions, and the actual course is going to start on 24th. So this is a weekdays batch, Monday to Friday. So let me get my calendar again. Give me a second here. Give me a second. Yeah, go back here. So Monday to a Friday is our actual database course. No classes on the weekend. Saturday, Sunday, no classes. So yesterday and today are two demo sessions, starting with the coming Monday, 24th June. We are starting the actual course, and the course timing is going to be same 8 a.m. to 10 a.m. 2 hours. And in EST, it will be 10:30 p.m. EST to 12:30 a.m. EST. That is Thursday to Sunday to Thursday. So in IST, it will be Monday to Friday, but in Eastern Time Zone, it will be Sunday to Thursday. No classes on the weekends. So course will be of 35 days, and the course fees will be of 10,000. That will be 125 US dollar. The course will be conducted using a Zoom session, and we're going to cover under 19C version. Right, so followed by what we understood about dedicated WhatsApp group for all the registered students. So we got a couple of students registered in our last few days. So all of them are added to WhatsApp group, and most of them are got a Google Drive access. Uh, Only few guys, like one or two guys, might not have got access. Probably I will grant access by today. Yesterday I was engaged with some other work, and then I could not able to grant those guys. But definitely after this today's session, I'm gonna grant access to everyone so that you can start looking into the course materials, start watching those previous batch recordings, and also you might see the current batch recording. So all will be granted, and then you can start looking into those contents. All right, so with that, in after yesterday's demo, so we got couple of students also got registered, and all of them also added to WhatsApp group. But please stand by for a few more hours. After this today's demo session, I'll be granting access to everyone on the Google Drive access. Right. So then, since this is a this course is a paid training course, fee is 10,000 or 125 US dollar. So the payment process, we have multiple payment processes. You can feel free to ping me on my WhatsApp number, or you can call me on my cell. So I'm gonna guide you through the payment processing. So that's once the payment is done, so we'll be getting access on the Google Drive and the WhatsApp group, and then we'll start communicating over there. Right. And followed by what we discussed yesterday, the prerequisites for this particular course, and very important. So if you don't meet the prerequisites, then the course is going to be very difficult for you guys. So what are the prerequisites? So this course can be best suits or can be attended by anyone, anyone in the sense anybody who is entering into this IT world, or anyone like who is a fresh graduate and start their career, or anyone want to switch their domain from non-technical to technical, or from any other domain to Oracle DBA domain, or anyone already working as a DBA like 2 years, 5 years, 10 years, or whatever. It doesn't matter. Anyone can attend this course, irrespective of whether they are experienced DBAs or fresher or switching their career into IT world. So anybody can attend this course because this course is formed based upon the my real-time experience of 15 years of experience as a Oracle DBA. As a DBA, whatever you are going to do day-to-day work for a client, so all those topics will be put together and then form this particular course. So because of that fact, and the other important fact is this particular course is formed such a way that it's going to start from the scratch, go till advanced level. So because of those two facts, this course can be best suits for anyone, so that anybody can attend this course. And then other prerequisites are if you already know the Windows basics, Linux basics, basics commands, and basics of SQLs, how to write a query and all. So you can easily catch up the things, and you can easily, learn this course, and you'll be up to date and you'll be in sync with me what I'm explaining. If you don't know these things, you have to put some extra effort and learn these things along with the course. We have materials uploaded into Google Drive. You can watch them and then self-study and then be on the top of this, so that whatever I'm explaining daily, you'll be able to catch up the things and you'll be in sync with me. So that is little bit extra effort you have to put if you don't know these concepts. But if you already know this one, then you'll be able to easily catch up the things and you'll be in sync with me what I'm explaining on daily basis. Right. Uh, Yesterday also I got few calls and few pings in WhatsApp about the lab requirement and all. Again, remember, so we are going to set up a lab on individual laptop, and you should have minimum of 10 GB RAM and 100 GB SSD hard disk so that you can set up your own lab and you can practice it. Right, and then few questions they asked yesterday that do I provide any labs? No, I'm not going to provide any live labs or the online labs. The labs will be set up on your individual laptop or desktop using Oracle VirtualBox. All right, so that's about the brief discussion what we did yesterday, and followed by a couple of topics what we discussed. That is database connectivity, like apps user connection versus DBA connection. So there will be millions of hundreds of app users who will connect with their user IDs and passwords. And once the connection is established to app server, via app server, the connection will go to that database using one single user, that's the application user. And as a DBA, we never connect using apps user. We'll directly connect to server. From the server, we are going to connect to database. Right, and then once we connect to database, and we're going to manage the database. So that is the DBA part. So let's continue with that discussion. whatever two things what we talked here, apps user will connect. So the connection will go to, for the apps user connection, the connection will be from the web URL. The web URL connection will go to app server. From the app server, and connection will go to database. So web URL, the client may be using web URL or desktop, or any software. He may be connecting to web UI or desktop or the software or anywhere that. So they will connect. So the connection will go to app server. From the app server, connection will go to a database. So that's your typical application user, how you will connect. But for the DBA, so we don't connect in matter. So we will, DBA will connect to server. From the server, connect to database. That is our DBA part. So DBA will directly access to the server where the database is running, and then we'll connect to database. So let's explore more on that. So right now here, let me get my lab. So this is my Oracle Lab 1 server where my database is installed. Let's say in simple diagram, this is your Lab 1 where database is running. So if I say talk about application connection, so application user will go with the URL, like amazon.com, icicibank.com, STL, hdfcbank.com. So the user will access that browser and he will enter the password, Malik, and his password. The connection will go to the app server. There'll be one or multiple app server. The connection will go using that username and password. That's application layer username and password. From the app server, the connection will go to a database. So here in the backend, they will be using app user, only one user. That app user will be inside our database. So that is application user, how they can, connect, how they can access it. But whereas DBA, what we'll do, a DBA directly connect to the server using the root user or using the Oracle user. Once they connect, from there they can connect to database. And let's say here in this example, Oracle Lab 1 is a server where we have connected to that server, and here the database is running. So database or database instance. So DevDB is the database which is running. So after connecting to root user, Oracle user, directly to the server, so I can see which database is running on this server. In this server, yes, DevDB database is running with Oracle user. So I'll just switch to that particular Oracle user and I'll set the environment. What is the SID? So we'll talk about this, what is the SID and all in regular class. So I have to run this .inv, set that SID, and then verify all the environmental variables are all set using this env environmental variable, my Oracle SID, Oracle base, Oracle home. So these are the keywords we'll discuss in our regular classes. What are these keywords? So once that is done, so we're going to use this DBA. So we'll be connected to database, connected to your Oracle database 19th Enterprise Edition. So once you connected to database, you can monitor, maintain, management your database as a DBA. So whereas application user or the end users, they will connect through user, connect to browser using their application username and password, and that connection will go to application server. From the application server, and the backend that's going to connect to database using that app user. So this app user will be defined inside the application server at the time of while installation of your application, right? So that is a flow how DBA versus how application is gonna manage. So many time DBA we manage, many of these application user will report that unable to connect to database. It may be this app user is locked, or this may be app user having some permission issue, or there may be a network connectivity issue between this application server and database server. So all those our day-to-day activities as a DBA will be keep on monitoring them. Alright, so that is a quick understanding of how application user and database user is going to connect. So we typically directly connect to server and we'll switch to that Oracle user and then connect to database and do day-to-day activities inside database. Right, so that's a simple understanding how application user like end user versus DBA will connect. So now a DBA wants to connect to database. It's all about administration. How can I administrate my database? How can I make sure that my database is up and running? How can I my how can I make sure that my database has enough space, enough storage, enough memory, enough CPU, enough RAM, so that the millions of hundreds of the end user will access my database will never crash. That's our day-to-day activity. That's our DBA job. That's a DBA goal. Make sure that your database should up and run, available 24/7. Now let's say we'll go a little bit in deep on this architecture part. What we covered yesterday is about a database architecture. So what we discussed yesterday is about a database architecture. If somebody asked, or it's going to be one of the common question in most of the interview. Can you brief or can you explain what is database architecture? Or can you explain what is instance? Can you explain what is database? Can you brief me what is a memory structure? What are the background process? What is SGA? What is PGA? What is shared pool? What is Java pool? What is large pool? What is server? Uh, what is like stream pool? What is database buffer cache? What is log buffer cache? What is UGA? What is stack space? What are the mandatory background processes? What is the job of S1? What is the job of P1? What's the job of log writer? Right? What are the data files? What is system data file? Sysocs. And what is their inside system data file? What is their inside sysoc data file? So those are the common interview questions you can expect whenever you are appearing for the interview for any DBA role. So these are the must asked or commonly asked question. What S1 will do, what P1 will do, what checkpoint will do, what deviator will do, what log writer will do, what's the use of shared pool, what's the use of large pool, what's the use of database buffer cache. All those will be like common questions. Right. So now let's go in details about the database architecture. So let's say, let me bring that one here. So this is the abstract view or overall architecture part, how the database architecture looks like. Let's say the client Malik user is connecting to database. The connection first will go to listener and the listener will take that username and password and then which database he is connecting. He is connecting to DevDB. So the connection will go to listener first. Listener will verify whether this particular username, password, and the connection details, which database he is trying to connect, are all valid, and this particular Malik user is authorized to connect to my database. And listener will come back, boss, you are a valid user. You can go ahead and then connect to my database instance. So then the user connection will be established here. So there's a one dedicated server process will start for the user one. So client one connected to my database, one server process will start and one PJ will start. Similarly, client to connect to my database, same thing, the connection very first time go to listener. Listener will validate whether that username, password, whatever the database details is sharing are all valid. And then listener will go back, boss, it seems you are a valid user. Go ahead and connect to my database instance. And this particular client too will get his own server process, and then he will be getting his own PGA memory. Same thing goes for your client 3. Client 3 is trying to connect. Again, connection will go to listener. Listener will validate whether he is the authorized user, and listener will come back, boss, you are authorized user. Let's go and connect to my database. So then client 3 will connect to my database instance. So this client 3 will get again his own dedicated server process, and then he will be getting his PGA private memory area or the program memory area. Right, so that is 100 or 1000 client connects and 1000 shared process, so the server process or the memory, PGA memory will be allocated. And then any transaction this client will do, it may be select query he will be doing, it may be update query he is doing, it may be delete some data is doing, whatever the transaction he's doing, all those transactions or all the queries will be executed by server process on behalf of that client. Any transaction, it may be insert, select, update, delete, all those transactions will be executed by respective server process. And in order to execute those queries, the memory will be assigned and memory will be helpful with help of PGA. PGA stands for Program Global Area or Private Global Area. It will be assigned to 1, 100 user connected, 100 server process, 100 PGA memory will be allocated. And then any query they execute, all those query will be executed by the respective server process. And for those server process, the memory will be associated is a PGA, private global area or program global area. Those memory component will serve those server process activities. And then all these hundreds or thousands of connections will connect to my database instance. And via instance, the connection will go to my database. The lower portion is your database, and upper portion here is your instance. The instance is nothing but a memory, as we talked in our yesterday's site. It's a memory, and it's your background process. Right, in the memory we have this HGA. HGA stands for shared global area or system global area. Inside that HGA we have shared pool, job pool, stream pool, large pool, database buffer cache, redo buffer cache. And inside that background process, we have mandatory and non-mandatory background process, checkpoint, SMON, PMON, debrider, logwriter, recoverer, archiver, so many background processes. At the backend, we have a database that's a data file. System, sysocs, undo, user, all those data files. So let's say where is that one here? Database architecture is the instance and database. Instance is a logical structure, database is a physical structure. Instance is made up of memory and background process. In the memory, HGA and PGA. Inside HGA, so many sub-memory component. Inside PGA, so many sub-memory component. And in the background, mandatory and non-mandatory, SMON, PMON, debrider, logwriter. And non-mandatory are your archiver, job queue, and other processes. At the backend database are the data files like systems, sysocs, undo, and users. And that's what I just draw in this abstract view here. Right, so yeah, in our regular classes, we will discuss in detail about each and every component. Along with the data files, we have control file, we have redo log files, we have archive log files, and how the DB writer will write data from buffer cache to data file, how the log writer background process writes data from redo log buffer cache to your redo log files, and how your server process is going to fetch the data from your data file to your buffer cache, from the buffer cache to your end users. So those all the flow or data access we'll discuss in details. So two main memory component in the SGA, or rather three main memory component will be heavily used for each and every transactions, or your shared pool, your database buffer cache, and your log buffer cache. These three memory components are heavily accessed or heavily used for each and every transaction. It may be insert or update or delete or select query. End user can do any of this: insert, update, delete, truncate, or create. It may be truncate or create or anything. End user can perform any of the transaction. All those transactions will be heavily accessed or done with help of these three major memory components: shared pool, database buffer cache, and redo buffer cache. Right, we'll go in deep dive in our regular classes, all these component and what's the flow, how the select query will work, how the insert query will work, how the update query will work, and then what are the flow and what are the execution plans and what are the data flow path. So we'll see it in our regular classes. Right, any questions here so far on the architecture part? So architecture part, only stick to this particular content what we mentioned here. And again, this is going to be one of the common entry questions. Can you brief about database architecture? Or can you explain about database instance? Can you explain about what is database? What are the data files? Can you explain about mandatory background process or non-mandatory background process? Give me 1 second, guys, here. All right, guys. Thank you for that. Right, so that's a brief intro about how the database architecture looks like. It looks to be simple by looking at this concept, but it's not at this point. Like, each and every component what I written here has its own specific set of jobs, and we have to go in deep about how that particular component will be used and component will be saved. In simple word, database buffer cache, I just said it's a one of the sub portion of your SGA. But inside the database buffer cache, lot of mechanisms happens. There are dirty buffer, there's a pinned buffer, there's a free buffer, and there's a cache hit, cache miss. Same thing if I go about your shared pool. Inside shared pool, again we have sub-memory component, library cache and data dictionary cache. In the library cache, we have SQL IDs. In the data dictionary cache, we have metadata of a particular table or the object. And then my optimizer is going to pick up that particular SQL ID. And whatever your query you're going to run, all the parsing is going to happen in the shared pool. So there will be like, huge complex tasks about each of these memory component and each of these PGA memory component. And there'll be set of job will be specified or done by each of those background processes. Yes, for example, S1 is called system monitor, P1 is called process monitor, CKPT, checkpointer, DB writer, and log writer. S1 is system monitor, which is responsible for making your database consistent. Meaning, whenever database crash happened, whenever your database is killed, or whenever server rebooted due to power outage, when you start your database next time, S1 is going to do your instance recovery or crash recovery based upon whatever data available in the control file and in the read log files. And S1 is going to do a roll forward and roll back. Whatever the committed data, it's gonna go for roll forward. Whatever the uncommitted data, it's gonna go for roll back. So that is a job of your SMON. And again, PMON, process monitor, which is responsible for monitoring all the connected users. If any users is idle timeout or connection is disconnected due to network, the PMON process is going to do a cleanup of those resources held by that particular user process, user session. right? So if I start talking each and every component, it will be huge. So we'll go in details in our regular classes, but at eye level overview, if somebody asked what is database architecture, your answer should be this 4 line, 5 lines, what I mentioned here. And definitely it is one of the common questions in most of the interview. Or if not, they will be asking you specific question about what is database buffer cache, what is shared pool, what is large pool, what's the job of SMON or the PMON or the DB. So specific component they may be asking in any interview. Right, so that's a abstract or detailed view of architecture. Now let's go further, understand few more topics like your user management, your TNS, and your physical versus logical structure. All of them will continue for the further discussion. There's a question in the chat here. If a user uh, run a simple query where it will be processed again, as I just explained, right? So it's not that simple to say how that query will be processed. So it will be part of, you have to understand one by one. So this diagram will tell you the user will be connected via listener. Listener will allow him to connect to database. The server process will be started and PG will be allocated. Any transaction he do, the very first thing, the transaction will go to shared pool. Whether that transaction is available on the shared pool, meaning the SQL ID will be available in the shared pool or not. If it is available, you'll directly use that one and go to database buffer cache. If it is not available, that query will go for parsing. Very first time they run the query, it's gonna go for parsing. And once the parsing is done, that query will be saved under that shared pool and then further goes to your buffer cache. In the buffer cache, whether that data is available or not. If the data is available, it will be given back to that end user. If the data is not available in the buffer cache, then query will go to data files and fetch the data into buffer cache. After that, give it back to that end user. There's a particular flow. There will be this flow will get changed or varies based upon what type of a transaction user is doing. Whether user is doing insert, whether user is doing update, whether user is doing delete, whether user is doing create. So based upon what query user is running, the flow will little bit get changed. But for the select query one, always it's gonna use first shared pool, followed by database buffer cache, followed by your data file. All right. So let's continue further now. One of the common questions you can expect, type of databases in Oracle. So type of databases in Oracle. So as we talked yesterday, standalone versus rack. Only two major types of databases, standalone versus rack. So this is simple understanding what we had yesterday. Where is that one here? In standalone, end user will connect application to that server. All the connection will go to my instance and then followed by your database. In rack, connection will go to instance 1, instance 2, instance 3, and then via it's going to go to your database. So we talked about the advantages and disadvantages is HA, high availability, and load balancing, well worth. So these are the major features which is not available in the standalone, but rack it's available. We talked about this in details yesterday, right? So this particular course, what database administration is based upon standalone. Rack is a separate course. Rack is a separate course, and standalone again. Rack course will be starting. If you see, will be starting in the next month, 6th of July. So in the standalone, you can say standalone with without ASM, standalone with ASM. Again, what is ASM? ASM is a automatic storage management. Like Oracle provided storage concept. So that is one of the topic. If you see yesterday, I explained that one. We have chapter number here, chapter number 9. We're going to talk about ASM overview architecture administration in details. So that is the Oracle provided storage concept. So with the help of ASM, we can avoid dependency on Linux admin or the storage admin. In order to create a database, you have to depending upon your Linux admin to make sure that storage is available, enough space is there, and your storage admin or Linux admin has to increase or decrease the storage. Then only we're able to create a database. To avoid that dependency, Oracle has provided its own storage concept. That's your ASM storage. So you can create a database. Let's say I have two servers, lab 1, lab 2. I can create my database here. Here also I can create my database. And this particular database is stored under OS storage. And this particular database is stored under ASM storage. Right. So if your lab 2 is completely controlled or the database here in the lab 2 completely controlled and everything is under DBA hand. So ASM storage we will manage. In the lab 1 where this particular database is under OS storage, we have to always depend upon OS admin to do any activities on the OS side. Like you want to increase the space on the OS side or you want to add a space on the OS side, you have to depend upon the storage admin. So here's the just best example. I have this lab 1 where my DevDB database is running. And same thing here, I have lab 2 where my test DB is running. But before the test DB, you can see ASM is running here. Whereas here, only DevDB is running, no ASM. Means this particular DevDB database running under OS storage. And this particular lab 2 test DB running under your ASM storage. So your ASM storage always starts with this plus. Let's say I want to connect to my database here. I can do select name from VDLR data file. So I have all this system, sysocs, undo users. These are your backend database. We'll talk about this one, right? A database is the data files. System, sysocs, undo, temp users, all these data files. If you see all these data files are under my OS file system. So I can go to this location. Right. So if I go into that OS storage here and do lsfnl, so I can see all those data files, physical data files, my end database. Same thing if I go to my lab 2, connect to that lab 2. test DB and run the same query. Right? Same system, sysocs, undo user. For this particular test database, again same set of data files. But these data files, remember where it is? It's an ASM storage plus data test DB data file. So if you try to go into this location, it never allow you to go into that location because this is not the OS storage. This is the ASM storage. If I go into that one, it says no such a file or directory. It's a plus data. Whereas your file system will be started with a slash. That's the OS file system where we can go into that location and see the data file. But whereas your database is running under ASM, that's the ASM storage, Oracle provided storage. You cannot simply go CD and then go into that location. For that only we have this ASM instance, and that's where we have a particular topic here, ASM architecture, ASM administration. So we have to go into that ASM storage. For that we have to set the environment to ASM, and we have to use something called ASM command line. ASM command line. After that it will be in the ASM command line. Now you can go CD into your ASM storage. CD. Now you are into that location, ASM storage location. Do LSF run, you can see all the data files. Right, so that is two types of database. What typically you see in the any industry or any customer, the standalone database means running under single server, single database will be running or single instance will be running, and that instance or that database may be under OS storage or maybe under ASM storage. Standalone database without ASM, standalone database with ASM. Here it will be a file system, OS file system, and here it will be ASM storage. That's a simple understanding for the standalone. And this particular DBA course is based upon these two type of database. We'll be covering both standalone without ASM, standalone with ASM, and these two type of database will be covered in this particular course. Whereas in case of rack, again, rack is a different concept at what I explained here. So rack also we have rack database, rack one node database. We have two types of databases over in the rack as well, rack database and rack one node database. So in rack course we'll be covering these two databases. So in typically at overview at high level, two types of database, standalone versus rack database. In standalone we have standalone running under file system, standalone running under ASM storage. In case of rack, it's a rack database or rack one node database. Alright, so those are your type of database in Oracle. There's a few questions I can take it here. Can we run Oracle EBS on ASM storage? Right. So EBS is a special database, e-business suites application, and your database can run under standalone, can run under standalone without ASM, standalone with ASM, or can run under rack, rack one node or rack database. All will be supported in EBS. It's a way where you store the data. That's it. Otherwise, your database architecture or database workflow, everything remains same, but only matter of where you are storing the data on file system or on ASM. It is supported. Uh, there's a one more question from Lokesh. If the DB has a storage under file system, we need a Linux admin to make any changes. Yes. So if you want to right now, my database is stored under this Linux storage. This particular mount point is full. Let's say how much space it is there right now. If I do df dash h, right now it is out of 84 GB, 49 GB is used, 36 GB is free. If this 36 GB is full, I have to engage Linux admin to modify or increase or decrease the space from there. That's the Linux admin dependency. Whereas here, my data disk group, I no need to, I can do lsdg list this group. My data out of 20 GB, 3 GB used, 17 GB is free. Whenever this data is full, I no need to depend upon Linux admin. I can go ahead and then myself I can increase it. Right. So that is where the DBA is going to manage the storage. In case of ASM, in case of file system, we have to engage the Linux admin. That's correct. All right. So any questions so far before I move into next topic? There's a one question in the chat here. Golden Gate is covered? No, in this particular course, we'll not cover any Golden Gate. And the data guard covered? Yes, we already discussed in our yesterday's class, right? So if you see our course curriculum here, the chapter number is that one. Chapter number right. Chapter number 18, data guard architecture standby database. So we're gonna cover in detail about data guard concept, building or setting up of a brand new data guard setup, simulating some demonstration like the sync gap between prod and DR, out of sync scenario, FRFL, all those things we're going to discuss in data guard. But Golden Gate will not be covered here. All right. So any more questions, guys, before right? Any questions anyone has, feel free to unmute and you can ask question here before I move on to new topic.
Malik, one question.
Yeah, please go ahead.
Okay, just an example. I have one standalone database which is hosted in Azure Cloud. So the storage-wise, it is in cloud, and we have the logical group volume. We have two physical volume over there, one with 5 TB and another is with 500 GB. So the total DB size is just near 5.2 terabyte, and there are some kind of performance issue. I want to create new physical volume with to get the better performance, like 2 TB with 3 physical volume. So altogether, I'm going to swap the existing data into new physical volume with 2 TB with 3 disks. And to do this rsync operation, does it need the database outage?
Right. So again, there is a different storage migration, storage motion technologies. So you no need of, and that is especially in the cloud, you no need of any downtime when you want to swap or move your disk or move the data. But there will be a database performance impact when you do a data movement between your volumes. But this can be done online. You no need of a downtime. But when you do the data movement, so that's a huge performance impact on the database side. End users queries will be like slow down. So again,
So there
this
won't be any
storage,
data integrity issues, which
no data integrity issues, but there will be impact on the performance of your database. And again, this is not recommended. You can do storage motion or vMotion or your data movement during the business hours. You have to do it on the weekends.
okay, got it. Thank you.
Malik sir, we are watching here.
Yeah.
Yes, with consideration to production related. So, what type of storage do we see in production? Do we have ASM storage or a file system storage?
So I seen it most of the customer with ASM storage, and at the same time, few customers still with a OS file system. Both are supported. I've seen both in the field. Many customers with both ASM and file system.
Okay, okay, got it. Thanks.
All right. Let's continue for the few more topics. Very first question, what I can say, the very simple question, how to, there are two concepts now. What we understood is two concepts here, right? A database instance is different and database is different. Instance is a logical structure, combination of memory and background process. Database is a physical structure where all the data files are resides. So two questions, how to check instance is running or not. How to check database is running or not. So instance is different and database is different. So you have to make sure that instance is running, but database is not running. Or anyone want to access database, they have to connect to instance. Without instance, they will never be able to access the database. Meaning, let's say I have the server lab1 and then all my data files are here. These are my data files. Whatever we seen here, right? Whatever the data files. This is your actual database. All the end user data is residing over here. In order to access this database on this lab1, you should have your instance should be up and running. This is your instance. And this instance will be having memory plus your background process. Any client will connect to instance. Via instance, they're accessing the data. Client 2 connect to instance. Via instance, they're accessing the data. So whatever we are going to do here, ps-if grep smon, that's going to tell you your database instance is up and running. So there's the two queries we're going to run to check that one. As a DBA, we're going to connect to database. We're going to do select instance underscore name, comma status from $, instance. We have to run this query and make sure that your instance is in open state. Then only that end user is able to connect to my database. How to check your database is up and running or accessible? For that, we're going to do select name, comma open underscore mode from $, database. So read and write. So I have to make sure that my database is in read write mode and my instance is in open mode so that end user can connect to instance. Via instance, they can able to access my database. If your instance is down, nobody can access your database. If the database is down, instance is up and running, nobody can able to access my database. So both should be up and running. Then only the application team or the end user can able to access my database. So other thing what we understood here, any end user want to connect to my database, they can give me a second. Right. So that is my primary job. Make sure that your instance is up and running, database is up and running. I have to make sure that run the database two queries, instance status and my database status. Both should be up and running. Then only end user can able to connect. So what we understood, the end user to connect to your database, what is important? The listener is important. Without listener, end user will not be able to connect. So other important, a daily task, daily activity, make sure that your listener is up and running. ps-ef grep at TNS. Here a TNS listener name is listener. So your listener is running and you can do LSNRCTL. This is the listener control is a utility comes with Oracle. LSNRCTL status your listener name. Your listener should be up and running and your database has to be registered with the listener. Then only end user can able to connect. How to check whether listener is up or not. So this is our daily activities. As a DBA, make sure that your database instance is up and running. Your database is up and running. Your listener is up and running. You have to run this LSNR CTL status listener and you have to it has to show your database registered with that listener. If the listener is down, no users can able to connect to my database. Let's say if I want to kill my listener, this is my listener process. I'm gonna kill this one. The moment I kill that one, if you check your listener status now, nobody can able to connect to my database listener or nobody can able to connect to my database. No end user can able to connect to my database because your listener, no protocol, no adapter, connection refused. None of the end users, my entire business is down if my listener goes down because listener is the one of the primary thing which is going to take the incoming request and then run it. So this listener we talked about yesterday, TNS underscore admin. TNS admin is a location where we keep listener.vara and TNS names.vara. These are the two files called the network config files. Again, those words, whatever I'm talking, might be, very first time you might be, listening, or you might be having a lot of questions on that. But those topics we'll discuss in our regular classes. But for now, just be in sync with me what I'm explaining. TNS underscore admin is a location where we keep this listener.vara and TNS name.vara. Listener.vara and TNS name.vara are called as network configuration files. Right, so we call them as a network configuration file. And what we talked about, listener.vara is a server side file. A TNS name.vara is a client side file. So listener.vara server side means where your database is running. Client side file means from which system client is trying to connect to database. Right, that's a simple understanding. So again, what is there inside listener configuration file? What is there inside a TNS name.vara file? So typically server name or IP address where the database is running. On which port your database is listening, on which protocol your database running or listening. Right, so those are the few things: the server name or IP address, where the database is running, on which port your database is listening, and which protocol your database is running. So if I go into that CD, Oracle home, network, admin. So this is a typical your TNS admin path. TNS admin under Oracle home, network, admin. This is a location. So this is my typical location here. Inside that, we'll be having this listener.ora file. So in this listener.ora file, name of the listener and which protocol your listener is configured, and which host your database is running, and which port your database is listening. So that's a typical entry in that. Same thing if I go with a TNS name.ora, our TNS names also will be of the same thing. Again, this is too early to talk all of this, but we'll take a separate chapter. If I go here, there's a networking chapter number 11. There's a networking. We'll talk in detail about listener, TNS, SQLnet.ora, and all those things. But just to give you a brief idea on that, are two very important files: a listener and TNS. Listener is on the server side, TNS is on the client side. And what is there inside that? So IP address, port, protocol, and all those things. All right. So let's move on to the next one. What I can talk here. Well, give me a second. Okay, let's go with this one now. How this database can be installed? What are the various methods or the various options we can install? So we talked about two types of database here: standalone and then rack. So in the standalone, again, silent method, GUI method, and various method. And in rack, again, there are various method to install. So in simple words, the installation process or installation types or process. So basically two types. One is silent or command line. You want to install in a silent method or command line, or you want to install GUI mode. These are the two types how you can install your database: silent method or command line, or the GUI mode. So again, if I go back my type of database, what I explained here, where is that one? Where are those? Okay, here. Standalone versus rack. In standalone, silent or command line or the GUI mode. If you want to install standalone database, this database or this database, you have two options: install in silent mode or GUI mode. You want to install rack database, you want to go with silent mode or GUI mode, any of those. But anyway, we are not covering this rack. Let's stick to only the standalone operations. Let's say I want to install my this one standalone without ASM. I can go with this option 1. With the silent mode or the command line. I can go with this option 2, GUI mode. Standalone without ASM. That's my lab 1 here. My lab 1 ps-ef grep smon, where my DevDB is running, which is running under my OS file system that we already saw here. These are my OS level. All the files are there. So I can go with either silent mode or command line mode. What are the steps? The step number 1, download 19C Oracle software. Where you download Oracle software? There are two methods. One is Oracle eDelivery or support.oracle.com. Go anywhere, Oracle eDelivery or Oracle support.com. Download your 19C software, unzip 19C software into a directory. Like right now, this is the directory. You can unzip into any directory. Download the software and then unzip software into Oracle home. We're gonna unzip here and then install the Oracle home. So inside this Oracle home, install the Oracle home. This is your Oracle home by running run installer. So let's say if I go to this location, ls, I have this run installer. I can run that run installer and then I can install my Oracle home first. Once the Oracle home is ready, I can go and then create database, DevDB. How I can create my database? By going into this particular create database by running ./dbca. So that will be under bin. Under this bin directory, if I go to this Oracle home bin directory, there's a dbca. lsfnl dbca. So I have this dbca shell script. I can run that and then create my database. That's it. So high level, 4 steps. Download your 19C software, unzip that 19C software into the directory where you want to install. That will become your Oracle home. The Oracle home is nothing but it's a software where you downloaded and unzipped on a server. So this is my Oracle home where I downloaded and unzipped. This is my Oracle provided software. So I can download that software from Oracle eDelivery or support.oracle.com anywhere. In order to after that unzip, you have to run this run installer. That will become your Oracle home. And after installing Oracle software, you have to run the DBC database configuration assistant. That's going to create a database, give the database name, and it's going to create your database. So that is your lab 1. Same thing goes for your lab 2. Remember, lab 2 is with ASM. Right here, lab 2. PSIFNEF grep SMON. So your database has to run under ASM. So these steps are remain same. Download 19C software, Unzip your 19C software. So same thing even on this lab 2 I have installed on the same directory. If I go and do ls, I can see same software. And if I go to my bin, ls-ldbca, same thing here. So but your database is the test DB. I given a name as a test DB. This has to run under ASM. But where is the ASM here? ASM is the storage. How this ASM came? That's where before proceeding with these steps, you have to first install your ASM software. Download 19C instead of Oracle software, ASM software from eDelivery or Oracle support. And the same thing, unzip your 19C database software, 19C database here, 19C ASM software into the location user on app, 19C, any location, grid. That's your ASM home. So right now, if I go to this location, ls, so I can see all the ASM software here. Unzip 19C ASM software into that ASM home. And after that, third step, install ASM home. So this is your ASM home by running grid setup. These three extra steps will come into picture. This is your ASM setup. Once you do ASM setup, you proceed with your database creation. So this will be followed by your step number 4, 5, 6, 7. Lab 1 is quick enough, straightforward 4 steps. You're gonna create your database. And lab 2, again same 4 step you're gonna do it to create a database. But before that, you have to set up your ASM. That's the 3 extra steps will come into picture. These all steps can be done using option 1, silent mode or the command line, or can be done using a GUI mode. So the preferred one, always go with the GUI mode so that you have a lot more control than the command line or the silent mode. All of them are like supported over here, right? So I'll take a pause here if anyone has any questions on the installation process or the TNSR listeners what we just covered or the architecture part what we just covered so far. Right, I'll take it as a no. All right, so let's go with the any other questions or any other topic you guys want me to cover. I'm happy to take it a few more minutes and then talk on that. Give me a second here.
Yeah. I would like to know that can a same ASM instance be used for two different databases?
That's a good question, I can say. Your ASM is always one setup. I
Okay.
have lab 2. It's only one type of setup. Like, I'm gonna set up my ASM here on this server. That's it. So there's only one setup per host. Once you set up your ASM, and you can create your n number of databases. I will create database 1, database 2, database 3, database 4, so on. I cannot have one database, one ASM, second database, second ASM. ASM is always only one. Once the ASM is set up on a server, that's it. So you can create n number of databases as long as you have enough resource like CPU, RAM, memory storage on that server. You can go ahead and create a multiple databases on that server, but ASM is always one.
Right.
Right.
So does it mean that the two different databases would use the same plus data of the same ASM instance?
You can differentiate, like, I want to create my test DB. I want to create my dev DB. I want
Mhm.
to create my UAT DB. So the data will go like this: data dev DB plus data test DB. The respective directory will be get created inside that.
Okay, got it. Thank you.
All right. May we install Oracle DB using GUI mode into minimal Linux installation? Yeah, GUI mode and your silent mode both are preferred one. So what is mean by minimal Linux installation? I don't know, like what's the meaning, what context you're looking for minimal Linux installation. Both are supported. Your GUI mode or the command line, both are applicable, and you can go ahead and then install it, whichever you are preferred or used to it. Right, and then let's say if nobody has a questions, I can quickly jump on to the one more topic.
Malik sir,
Yeah,
hello.
please. Yeah, please go ahead.
Yes, Malik, though you have mentioned you are starting the RAC course on 6th of July. So as of now, we are covering Oracle DBA. So can we register and go with the same flow for
I-
RAC as well? Because we
If
did with
you no, if you are already working as a Oracle DBA and you know the DBA background, you can do both parallel. By the time next month 6th, we'll complete half of this database training, and you can catch up both the things. If you are a new and starting your career into this DBA or the fresher, then first complete this database course. Once that is done, you can go for the rack one. Later, we're gonna start the next batch that you can enroll it.
okay. Oh, oh.
All right. Okay, let's talk about few more files. Let's say I just mentioned about where's the architecture part. Is that enough, right? Like let's say I just talked about database architecture, instance database, and the instance is combination of your memory and background process. Memory is your SGA, PGA, inside SGA, so many sub-memory component. Let's say I want to quickly show that one. I can do show parameter SGA. So these are my SGA max, SGA miss, or you can do with SGA target. So SGA defined as a 3 GB for my database. And if I do show parameter PGA, so PGA defined as a 2 GB for this particular database. That's your memory component, HGA and PGA for your instance. And instance is the memory and background process. So memory is nothing but your HGA and PGA. And background process are nothing but mandatory and non-mandatory. S mount, P mount, log operator, checkpointer. So I can do PS-EF, grep, dev DB. So these are your background processes which are running on the server. So we have a PMON, mandatory background process. We have a DB writer, log writer, checkpointer, and we have SMON. Those are mandatory background process. Apart from the mandatory background process, you have a recoverer, you have LRUG, you have MN, MMNL, MON, and you have archiver, so many other background process. Let's say I have this TT02, TT01. So I'm just gonna kill this one. Background process, one of the background process for your database. I'm gonna kill this one. This is a non-mandatory. Let's say here Mandatory are these many, 5, these are 5 are mandatory, and non-mandatory there are so many. So one of them is this one. So let's go ahead and kill that one. The process ID. Kill -9 OS command, killing that process. You killed a process, but still your database will be up and running. Smon SQL plus /s sysdba. I'm able to connect to database. So non-mandatory background process, not a critical one. Even if you kill, it will wanna automatically get started. But mandatory process, if you kill, your database instance will go down. Let's say I can kill one of the mandatory background process. Let's take smon. We have this smon here. This smon has a process ID 15867. I'm going to kill -9. So your smon is killed. Smon is a critical background process, mandatory background process, which is got killed. And now try to connect your database. Connected to idle instance. Earlier when we connect, it says connected to your Oracle database 19C Enterprise Edition. But here, connected to idle instance. Let's try to query. Nothing is going to work here. So I'm just going to run the same query what I ran here. Check my instance status. Oracle is not available. Right, so that is your mandatory background process. So your smon, pmon, checkpointer, logretor, if you kill any one of that, your database will go down. Your instance will go down. I have to do startup. It will start. Alright, so that is your a memory component, SGA and PGA. How we can query it, connect to database, and do show parameter SGA, show parameter PGA, and sub component, and all will be available over there. And background process, mandatory, non-mandatory. Non-mandatory, you kill it, nothing is going to happen. Mandatory, you kill it, your database instance will go down. You have to start it again. That's what we did here, started. And at the back end, you have all the data files. Select name from VDLR data file. So this is your backend database. Do ls-l. You have all the data files. It's your database. System undo user. So that is your abstract or like simple understanding of your database. So apart from that, there are so many other files which is going to helpful, which is going to support your database operations, like your p file or sp file, control file, redo log file, archive log file, and your trace file or trm files, or before that here password file, your alert log file. Right? There are so many other files what you can see it at the database. Let's say I'll connect to my database again. Show parameter sp file. I have this sp file, and at the same time we have p file. Select name from VDLR control file. So I have this control file 1, control file 2, two control files. And redo logs. Select member from VDLR log file. So I have many redo log files. And then archive log files. Archive log list. Show parameter. Again, these are commands you will be able to handy once you start hands-on lab exercise. If I go into fast recovery area, DevDB, archive logs, and if I go with the today's date, So today date nothing. Let's go to previous day. Right, nothing. It is not yet generated any archelog, no transaction on this database. I can quickly do one log. I'll go to today's directory, and right now no archeologs. I'm just going to connect to my database. I can create one archeolog manually because this database is a lab. Ideally, if there's any transaction, it's going to generate the archeolog. But this is idle database, no transaction at all. Alter system switch log file. Manually, we're creating the archeologs. Right, not yet. Let's connect back. Where is archeolog location? We can check it out. Show parameter log. Show parameter log. Archeolog is set to null. If archeolog is set to null, so default your archeolog will go into your Oracle home DBS. No. Okay, so I can verify that one. Where is the archeolog location set? So that is your archeolog, followed by your password file. Again, what's the use of password file and all those things? We'll get to know in further, like under the same Oracle home. I'll set the environment back once again. DB cd dollar Oracle home cd dbs. You have Vara pw db. So this is your password file. And what's the use case why we need a password file? We'll explain in our regular class. And the trace and TRM file. So locate alert underscore devdb.log. So we have this alert log file. Any database activity, you can see it on this alert log. And the same trace location, you have all the trace and TRM files here. Trace, TRM, all those files will be available on this particular location here. Right, so those are the files which are needed for. Some of them are very, very critical. If you don't have a control file, your database will never run. And some of them are diagnostic or some of them are monitoring files. So which are needed for your database operations. So we'll explore more when we start our regular classes, but just wanted to give some heads up, like not only your database architecture understanding will complete your database. Along with that, there are so many files which is at the back end helpful, and each one of them has its own unique job. Without SP file and P file, you will not be able to start your database instance. This is the first file which will be read when you're starting your database instance. After that, control file, after that, read log files, data files, and all those things will come into picture. That we'll cover in details in our regular classes. All right, I'll take a pause here. I don't want to continue further because it will be too much if I start explaining. We'll take it in our regular classes step by step in details. But yeah, before we wrap it up or wind it up for today, so any questions or queries so far, whatever topics we covered, or any questions or any queries you want to clarify it before we wrap it up? There is a question from the Ram here. How many databases we can connect to one instance? So there is a one misconcept, like in MS SQL or IBM DB2 or SAP, so many other database technologies. It'll be like instance mapped with many database. Like I can create instance one and then DB1, DB2, DB3, DB4, DB5, like that. One instance and many database mapping. That is on MS SQL, IBM DB2 and SAP HANA. Whereas Oracle, it's not like that. It's a one instance mapped with one database. If I create my one instance and I create my database one, if I want to create one more instance, that has to be for the different database. It's always one-to-one, one instance mapped with one database. But whereas other database technologies like MS SQL, IBM DB2 and all, one instance, inside that you can create multiple databases. Two different concept between Oracle versus other database. Right.
Malik, you suggested that there's a PGA which gets associated with every server process.
Right.
So the entire PGA is, for an example, 1 GB. So that means, and each server process utilizes
Based upon the need. The moment one user connected, one server process started, and default 3 MB memory will be allocated. Based upon that, user runs any query, select query, insert query, update query. If you need more and more memory, the PGA memory will be allocated, and that PGA memory will be allocated up to whatever the PGA you defined inside your database.
yeah, total
Right.
PGA that we define inside our database.
Right. So we defined PGA aggregate limit as a 2 GB. That server process gets up to maximum of 2 GB, not more than this.
Yeah, but if one server process gets 2 GB, then rest of the server process wouldn't be left with any kind of PGA available to them.
No, all the server process will get up to 2 GB.
All the server process will get up to 2 GB, is it?
Yes, 100 user connected, 100 server process, 100 connection will be having 2 GB into 100.
Okay. So, okay, until it gets exhausted completely, the server memory gets exhausted.
Yep, that's correct.
Thank you.
All right. If no questions, let's take a break. We'll continue in our regular classes with a regular schedule. Again, if anyone interested, feel free to reach out to me on my WhatsApp number or cell number for any further queries or clarification or any payment processing. I can guide you through that, and then we'll start from Monday onwards. All right, guys. Thank you and happy learning. We'll see you on Monday. Let's wrap it up for today.
All right. Thank you.
Thank you. Yeah. Bye.
Thank you. Thank you.